Students, welcome to class. I hope you're doing well with your sub today. You're going to be working on the in-class lesson 6.4. Your homework is to do the preview video and notes for 6.5. I will be collecting both preview notes this Friday, 6.4 and 6.5. Also remember that you have an extra credit ALEKS quiz coming up on the 15th, due on the 15th. As of now, your cell phone should be turned off and zipped up in your backpacks. Please place your backpacks under your desk. Taking a look here at your new notes. Put your name on them, and let's go through. This will take us about 15-20 minutes to get through the basic examples, and then you guys will be on your own correcting page by page. Taking a look here, we've been working on the quad family tree. We've been here at the OCD family of parallelograms, rectangles, and rhombi. That was last class. This class, we're going to be over here on the non-OCD family. Taking a look at your notes, we're first going to look at things that make all trapezoids in common. So on the left is a standard trapezoid, on the right is an isosceles trapezoid. So regardless on how these trapezoids look, they have these three things in common. Step 1, trace the parallel sides. These red lines are parallel. Those are called the bases. I'd like you to write the word base and base. And the definition of a trapezoid is that it has one set of parallel sides. That's the definition, one set of parallel sides, and that's what makes all traps in common. Next, if you stake a set of parallel lines and stretch them out, and then I'd like you to darken one transversal. I would call that a stir stick, if all the way back in October. I'd like you to sweep these two angles. If you notice, these are consecutive interior angles. They're not congruent, but they are supplementary. So that's common to all trapezoids. These are called the leg angles, the angles connected to the legs. The leg angles are supplementary. Third thing that's common to all trapezoids, eyeball the midpoint here and the midpoint here and connect. That is called a median. And in all trapezoids, the length of that median is equal to the average of the bases. Remember, the bases are the parallel sides. So base plus base over 2. So the median equals the average of the bases. These are the three qualities of all traps, whether it's a standard trap or an isosceles trap. Okay, let's see what's unique about an isosceles trap. On the left is a standard trap. On the right is an isosceles trap. There are three unique things. And they all start with congruent. So I'm just going to write three congruent signs. First one, the isosceles trap is unique because it has congruent legs. So trace, hatch, it has congruent legs. That's the first congruency. Next congruency are if you can sweep this angle and this angle connected to the base, hatch, and sweep this angle and this angle connected to the other base, double hatch. Those are called base angles. And an isosceles triangle, those are congruent. So you have congruent base angles. Next one, put a dot here and a dot there and connect one diagonal. And put a dot here and a dot here and connect the other diagonal. Now I'd like you to finger pinch, please. Finger pinch the purple. Put your thumb and forefinger, pinch that distance. Now swing that distance around and finger pinch on the green dots. And you should notice that the diagonals are also congruent. The congruent diagonal lengths. Now they do not bisect each other, but they are congruent in their lengths. Now here we have a kite shape. Rather than me tell you everything that's on a kite, I'm going to set the timer for 1 minute, and I'd like you to mark everything you think you know. Mark everything you think you know is true about this kite. And then the video is going to pick up again, and I'm going to go over what you think you know. So 1 minute, mark everything that you think you know is true. Okay, let's see what you marked here. Step 1, and the most important, is the fact that right in the middle here, of course, is a right angle, and it goes a right angle all the way around. That's the most important thing you should have marked, is that you have 4 right angles. Second, you have consecutive congruent sides. Third, these segments from here to here and here to here are congruent. They are cut in half. But very importantly, from here, the dark pink and the light pink, those are not congruent, so there should be no hatch marks there. Now the angles along the elongated side, these are called vertex angles. So I'm going to sweep them in red. Here and here are called vertex angles. Now these vertex angles have 2 very important properties. The vertex angles, they are bisected, but they're not congruent. These vertex angles, they are bisected. They get cut in half, but they are not congruent to each other. In fact, this should be double hatched down here. They are bisected, but not congruent. Those are called the vertex angles. Now these angles here, the purple ones, very important. These angles are congruent but not bisected. They are congruent across from each other. These crossbar angles, call them crossbar. These are congruent but not bisected. So just to recap here, The vertex angles. The vertex angles, they are bisected but not congruent. And the crossbar angles, those are congruent, but they are not bisected. Take a moment and write that down. Now, before we do 3 sample problems, I'd like you to stand up and take a stretch. Ask your neighbor what they're going to do over the break. You get a 1-minute stretch. Stand up, take a stretch. I'm going to set the timer for 1 minute, and we're going to sit back down for our examples. You're stretching. Ask your neighbor what they're doing over break. Alrighty guys, back to the kite. Have a seat. I want to do 3 examples together. You're looking at page 3, please. Page 3. Okay, we have a trapezoid here. Step 1, I'd like you to trace the parallel sides. Put the little arrow feathers on there. Now I'd like you to sweep the angles that are involved. And extend your transversal. I call that the stir stick. Now remember, these are not congruent, but they are supplementary. What I'd like you to do is, if they're supplementary, we're going to write a thing equation first. Things first. You always write things first equations. So I'd like you to write this equation out. Angle plus angle equals 180. That's the definition of supplementary. Now I'd like you to circle, plug, chug with me. Angle, pick it up, circle the other angle, .180, of course, is just 180. All right. Not only must you solve for x, but you also must show some sort of check to be assured. I'm going to give you a minute. Go. Okay, let's see how you did. So you should have gotten, you collect like terms, and you should have gotten 9x plus 90 equals 180. So we end up with 9x equals 90, and x, of course, equals 10. Now, how do you know you're correct? Let's check. Right here, 9 times 10 is 90 minus 10. We get 80. So we put 80 here, and we ask ourselves, does 100 plus 80 equal 180? And the answer is yes. So that is, you plug it in, and you know that you have a check. So the basic rule here was that the leg angles add up to 180. Let's take a look at example number 2. Example 2, we're going to be working with the side lengths here. And the lengths we're going to deal with is first the median. So darken the midpoint, midpoint, connect. That's called a median. Write that up in the box here. Median equals. Trace with me. Base plus the other base over 2. The median equals the average of the bases. Base plus base over 2. Remember, when you write equations, equations have two sides with an equal sign. An equation has two sides with an equal sign. Now we're going to solve for our unknown here. So we're going to circle, plug, chug. So we circle median, pick it up, base plus the other base. Don't forget the over 2 part, so we even circle that. Whenever you have a fraction and a non-fraction, you just make the non-fraction a fraction over 1. I'd like you to solve for the variable and show some sort of a check. Solve for the variable, show some sort of a check. You have a minute. Okay, let's see how you did. So we're going to cross multiply. We're going to end up with 15 times 2 equals x plus 3 plus 4x plus 7. We collect like terms. We're going to end up with 30 equals, you should have 5x plus 10. And when you solve for x here, you should end up with x equals 4. You're not done. Let's plug it in and see what happens. We plug in x up here, and we have 4 plus 3, so we get 7 up here. And down here is 4 times 4 plus 7. Of course, that's 23. And now let's check. If you add 7 plus 23, you get 30 divided by 2, 15. Check. That's how you know your answer is correct. The bases average to the median, which is 15. All right, we have one more example. One more example. But before we do that one example, I'd like you to stand again, take a quick stretch, and now I'd like you to ask another neighbor, what are they going to do over winter break? All right, let's tackle that last problem together. It says right here that a kite, STUV, has a shorter diagonal, SU, and a longer diagonal, TV. The shorter diagonal is 12 inches in length, and the wider of the two vertex angles is 120, and the smaller of the two vertex angles is 60 degrees. Find everything you know. We just filtered. Now we're going to draw one step at a time. We have a kite, STUV, and we have a shorter diagonal of SU and a longer diagonal of TV. There's our kite, and we have a shorter diagonal and a longer diagonal. The shorter diagonal has S in it, so we're going to start the S right here. And then we have to go in order like so. So S, T, U, V. Now let's check to see if our dimensions match. SU is shorter. Trace it, S to U. And TV is longer. TV. Okay, it matches. So now we cross it out. We've taken care of that. We are told that the shorter diagonal is 12 inches, so from here to here is 12, all the way across. That means we're going to split it in half. It must be 6 and 6, because that crossbar gets cut in half. We also have right angles here. And then now we're going to talk about the vertex angles. The vertex, the wider of the vertex angles is 120. This is the wider of the vertex angles, that's 120 degrees. And the smaller of the vertex angles is 60. So that's down here, that's 60 degrees. We're going to find everything possible at this point. What I like you to do is you and your quad mates attempt to squeeze out as much information about this using the properties of a kite in 1 minute, and then I'll go over the problem with you. You're attempting to find everything you can find about this diagram. Okay, let's see how much information you got out of this. Well, hopefully you noticed that if that's 120 and this is cut in half, that this is 60 and this is 60, and that's 60, this is going to be cut in half, 30 and 30. We're going to work on this triangle first. We're going to take it and split it apart. Hopefully you notice that we have a 30, 60, 90 triangle here. I'm going to pull it apart. We have a 30, a 60, and a 90, and we have 6. So I'm going to pull the table out right here. You should be writing this down too. Short leg, long leg, hypo. The short leg is just the short leg. The long leg is whatever the short leg times root 3. The hypo is whatever the short leg is times 2. So looking at this pink, this 6 here is across from the 30, which is the smaller angle. That makes this the short leg. So circle this, that's the short leg, draw an arrow to the hypo, and our function box is times by 2. So of course 6 times 2 is 12. Now we're going to go to the long leg. So circle short leg again. Long leg is times by root 3. So this piece right here is 6 root 3. Let's put this on the diagram. So far what we have is this length is 12, and this length is 6 root 3. This length is also 12. Now up here, we're going to pull this one out in blue. Follow along. This is 30, this is 60, and 90, and now the 6. Now be very careful here. The 6 is no longer the short leg. It's now across the larger angle, so the 6 in this blue triangle is now the long leg. I'm going to blow this up so you can sit real close here. So this one gets a little tricky. What you ask yourself is this. We take the short leg and we're going to times by root 3. So it's something times root 3 is 6. Let me put this in the margin. Something times root 3 is 6. Ask yourself what this something is. You should have gotten 2 root 3. Because 2 root 3 times root 3 is 6. So this length right here is 2 root 3. And then to go to the hypo, you simply times by 2. So 2 root 3 times 2 is going to be 4 root 3, which makes this 4 root 3. Okay, so once again, just like a rectangle, when you're told something has the properties of a kite, you have a lot of information going on there. All right, students, you're going to work through pages 5, check it on the board. 6, check it on the board. 7, check it on the board. 8, check it on the board. 9, let me give you a heads up about 9. 9 has not exactly a typo, but just do this right now. When you get to 9, you'll understand. Go like this, and just make both of those 9 units. You'll understand when you get to 9. Pages 9 and 10 go together. 10's the workspace for 9. 11 and 12 go together. To do 11 and 12, you're going to need some red hand tiles. The red hand tiles are in the back of the classroom, some red trapezoidal tiles to help you with page 11. Then the information from page 11, what you discover, carries over to the next page, 12. Your sub has been given permission to do extra credit sign-offs. So if you finish in class, your sub has permission to put a plus 12 out of 10, then you turn that in on Friday for those 2 points extra credit. Good luck, students, and I look forward to seeing you on Friday.